Welcome. Today we're talking about reinforcement learning. So reinforcement learning, or RL, is a computational intelligence which mimics the way humans interact and learn from the environment. RL is neither supervised nor unsupervised learning, but lies in between. The term used in reinforcement learnings are the agent, which is an object moving and doing the learning for the environment. So the environment itself is where the agent is learning from. State is the current circumstance of the agent in the environment. Action refers to the next steps which the agent may take. Reward or penalties are reinforcements received from the environment. Introduction to Q-learning. In Q-learning, the agent interacts with the environment and learns from the rewards or penalties obtained. Q-learning is based primarily on two tables, the P table, which are the rewards, and the Q table. Each table are represented by the states and the columns as an action. The Q table is first initialized at start. The training phase is where the Q table is updated. During this phase, the Q table is updated for each exploration the agent performed. A balance is required in this phase between exploration and exploitation. So the formula below is for the Q values. So for each state, the action in the state is columns are updated according to this equation. The taxi problem. The taxi problem is where a taxi, the agent, is meant to pick up 1 to 5 passengers and drop the passengers at particular spots where for each wrong drop-off, the taxi accumulates a penalty. So there's two ways we solve the taxi problem. One is by brute force and one is by Q-learning. So you can see in the brute force where we recorded the time step to solve the problem. In the brute force, we took up to 200 steps to solve the problem for one running time, whereas in the Q-learning, the time step got very low from 17.5 to about 7 time step. The Q-learning is even better when we talk about penalties. So in the outcomes of brute force, the agent was collecting up to 80 penalties per run, whereas after the Q-learning, there was no penalties accumulated at all. So how are we achieving this? So the main difference is brute force goes back and randomly just keeps looking for dropping or picking up passengers, whereas in the Q-learning we go for a training where we explore the area, update the Q table, and when we apply the Q-learning, we use that Q table. So when the next action for the agent to take is based on the Q table, so it's knowledgeable what it's doing next. It's not random. So the mathematical representation, the Markov process applies probability when moving from one state to another. The Markov decision process is where reinforcement learning comes in place as the terms action and rewards come into play. The agent role is to maximize return over a certain period t. The overall reward return is denoted by GT. So to maximize the overall reward, we change gamma from 1 to 0. So the agent increases the importance of looking for the overall reward instead of immediate rewards. Introduction to the cart pole problem. The cart pole problem involves balancing a pole on a cart for a period of time. Two solutions are used to solve this problem. random method, and the hill climbing algorithm. So when we're doing those two methods, it is very close to neural network. The algorithm used to solve the carpal is an application of neural network. The action is a product of weight and the observation. So the weight is changed until a more efficient one is found. In the random method, the weight is chosen randomly and randomly changed each time, after which we pick the weight that resulted in best action and use that. In the hill climbing method, the initial weight is random, but then is changed in small increments until the best weight is obtained. Limitation of applying neural network for reinforcement learning. The limitation for random method, as the weights are randomly generated, a large amount of time is required to find the right weight. Hill climbing method, the weight is randomly initialized and increased or decreased by a small increment. Issue may arise when the initial weight is past the most effective weight and the weight is growing, thus the solution might never be reached. Introduction to cliff walking. Cliff walking is about an agent X moving through an environment where C represents a cliff with penalties of 100. Solving the cliff walking problem with brute force and reinforcement learning. As per the graph below represents the amount of time steps required to solve a problem. In the brute force, we can see up to 30,000 steps before the solution was found, whereas in reinforcement learning, the agent took a constant amount of steps, which is about 13, to solve the problem. The difference here between taxi problem and the cliff walking problem is that there are no rewards in the cliff walking, so there is no need for the agent to explore as much as a taxi problem. Hence, as there's no reward, the only reward is to finish the problem at the same amount of time, which is about 13. Introduction to temporal difference reinforcement learning. In the temporal difference method, the next move is based on the action values. In the equation below, there are no reference to rewards. Solving the cliff walking and taxi problem with temporal difference reinforcement learning. As a TD learning is moving the agent with respect to action and state, instead and not on reward. Even though the agent is reducing the total accumulated penalties, the penalties are not zero as from Q learning. Conclusion. The report represented 3 different types of reinforcement learning. Each has merits and limits. Choosing the reinforcement learning algorithm needs to be based on the problem. For example, the Q learning is better than TD learning for the taxi problem, but for an instance where rewards is not important, TD learning can be used. Furthermore, we can see the learnings from SRT 215 being applied in the reinforcement learning. Neural network is used in the hill climbing algorithm to solve the carpal problem. The Q-learning applies the Bayesian AI with probabilities. State space search is used as we can look at the problem as a tree. The normative decision theory is applied to solve the problem using the reward-based methods. And the Markov decision problem is implemented to update the Q table. using the mathematical equations. Thank you very much for your time, and we'll see you next time. Thank you. Bye.